Hello students, welcome to lecture 3 of alcohols, phenols, ethers. In lecture 2 we have done the preparation of the alcohol from a alkene. That first reaction we learned over there was acid catalyzed hydration. Then we learned about hydroboration oxidation, right? Then now we'll do under alkene only, that is addition of H2SO4, addition of H2SO4, that is sulfuric acid to alkene. You take any alkene, a symmetrical alkene. Let's take this CH3, CH, CH2. Okay, this is the alkene, and you add a sulfuric acid, H2SO4. Now, there is also a negative part of the sulfuric acid and the positive part of the sulfuric acid. So, sulfuric acid structural formula is this way. This is sulfuric acid, H2SO4. Let's say it gives one ionizable ion. It gives you, here it is OH. Let's say it gives one ionizable ion. So this is OH S double bond O, and this side it is O minus plus H plus. So this is the negative part. This is the negative part of the H2SO4. This is the negative part. This is the positive part. So negative part will go to the carbon which has less number of hydrogen, right? We'll keep this one rule in mind whenever there is an addition reaction taking place on a alkene. So this is CH3, CH. How do we write OSO3H? Okay, it is written this way. In many textbook, it is written this way. This gives you CH3Y. One of the hydrogen is gone there. And further, if you do the hydrolysis, further you add a water to the hydrolysis, means breaking of some bonds to form what? Uh, to form alcohol. So this is CH, this is OH, and this is SO3H. Sorry, CH3. Now, which bond is broken over here? It is this bond. If you see, it is this way. O SO3H, or we can write SO2OH. You can write it this way also. OSO2OH, same molecular formula. So this bond is broken, then you get a alcohol. And here also we get a secondary alcohol. We can say that we get a Markovnikov's product. Product mechanism is not Markovnikov, it is a Markovnikov's product. Okay. Next method of the preparation of the alcohol, I'll write this is to be a third method, that is reduction of carbonyl, reduction of carbonyl. Now, what is the meaning of carbonyl? Carbonyl means it is either aldehyde functional group, either aldehyde functional group or a ketone. Aldehyde means we are addressing to this aldehyde or a functional or a ketone functional group. So reduction of the ketone. So before we go into the reduction, I'll just give you one flow chart. This flow chart, student, remember that it is going to help you in many of the reaction. It is not only going to help you over here, not only in this chapter, but it is going to help you at in a chapters like aldehydes, ketone, carboxylic acid also. 1 minute, what is this happening? So keep this flow chart in mind. Okay. Uh, we'll start with that flow chart. What is that flow chart? If you take a primary alcohol, now you understand what is the meaning of primary alcohol. If it is a primary alcohol, okay, and if you do the oxidation of the primary alcohol, see, flow chart is very simple. If you do the oxidation of the primary alcohol, what you do? Oxidation. What you are going to get is a aldehyde. What you are going to get is a aldehyde. Okay, this is the aldehyde which you are going to get. Now, if you do the oxidation of the aldehyde further, what you get is a carboxylic acid. Oxidation of the aldehyde gives you a carboxylic acid. It gives you a carboxylic acid. Now, what is the meaning of this primary alcohol and why it is called as a oxidation? Like primary alcohol, we'll take an example. This is an example I am taking, one of the example of the primary alcohol, right? Here, this is getting converted to aldehyde. Which aldehyde? It is this aldehyde, CH3, CH2, C double bond OH. Why this is an oxidation? Why this is called as oxidation? From here to here, why this is an oxidation? See, definition, one of the definition of the oxidation, there are two definitions of the oxidation. Like I'll consider two. One is addition of oxygen, one is addition of oxygen, and other is a removal of hydrogen, removal of hydrogen. These are the two definitions. There are more, but I am just focusing on this. So removal of the hydrogen. If you see, there is a removal of the hydrogen, right? There are here on this carbon there are two hydrogens. On this carbon there are no any hydrogen left, right? So this is what the this is that's why this is an oxidation. Further, if I do this, further if I do the oxidation of the aldehyde, what I am going to get is a carboxylic acid, CH3, CH2, C double bond OH. Now, why this is an oxidation? Because from here to here, there is a addition of the oxygen. You see, there was no oxygen over here. There is a oxygen is added. So here, from here to here, there is removal. Removal of what? Removal of hydrogen. And from here to here, it is addition of oxygen. Addition of oxygen. Right? You can just remember this process. You can just remember this. Alcohol getting converted to a aldehyde if you do the oxidation, right? And aldehyde and carboxylic acid will get converted to the aldehyde will get converted to the carboxylic acid. But if you do opposite of this means what? Opposite means this I am talking. I'm talking of the reduction. If you do the reduction of the carboxylic acid, you will get a aldehyde. And if you do the reduction of the aldehyde, you will get a primary alcohol. Understand this. Now, our topic is a reduction of the aldehyde, reduction of the carbonyl. Means we are going to do the reduction of the aldehyde. Now, one more thing, student, it will have you will have to remember certain things, which is a strong oxidizing agent, which is a strong reducing agent. Okay, now if the reducing oxidizing agent is very strong, then reaction won't stop at aldehyde. It will directly get converted to a carboxylic acid. If the reducing agent is very strong, then carboxylic acid reduction won't stop at aldehyde. It will just stop at a primary alcohol. This is the whole thing. Now coming now what if we take a secondary alcohol? If we take a secondary alcohol, I'll write over here. So keep this flowchart in mind. Secondary alcohol, secondary alcohol. If we take a secondary alcohol and if we do the oxidation of this secondary alcohol, oxidation we are doing, what we get is a ketone. What we get is a ketone. Now, further oxidation of the ketone is possible if you do the oxidation. Then again, you are going to get a carboxylic acid, but this require a extreme condition, high temperature, and a very strong, very strong oxidizing agent like a KMnO4. I'm going to discuss all these reagents and all. Don't worry about that. But this is the thing, ketone. Oxidation, and if you reduce the ketone, what you are going to get is a secondary alcohol. I can take the example this way: CH3, CH, CH3, and this is OH. This is a secondary alcohol, no? And if you do the oxidation of this, what you are going to get is C double bond O, CH3. Here, this hydrogen and this hydrogen is removed. So this is oxidation. Why? That is a removal of hydrogen. That's why this is a oxidation. So remember this. This is primary alcohol. This is sorry, secondary alcohol giving you a ketone. So this is the whole flow chart. This will help you a lot for many of the reaction. You don't have to by heart any of the reactions. If you can remember this flow chart, it's very easy. The organic chemistry will become more and more easy. Now coming to our topic. coming to our topic, that is reduction of the carbonyl. We'll do this. Reduction of the carbonyl. Reduction of carbonyl. Now, we require a reducing agent. We require many reducing agents over here. We'll talk about, so for the reduction, what is required? For reduction, what is required is a reducing agent, right? So what I'll do over here is I'll list some of the reducing agents. So first reducing agent I'll talk is about the hydrogen. Okay, this is the first reducing agent, that is hydrogen in the presence of platinum, palladium, or nickel, any of this. This is a very good reducing agent. It reduces like carboxylic acid to aldehyde. It can reduce, remember this, it can reduce carboxylic acid to aldehyde, and it can also reduce aldehyde to primary alcohol, right? And it can also reduce a double bond. Remember, reduction of the double bond. It can also reduce a double bond or a triple bond, double bond to single bond. Okay, and it can also reduce triple bond to double bond. Okay. Means carbon carbon triple bond. Remember this. Uh, like if there is a case this way, if it is a case this way, CH3, CH2, C double bond, OH. And let's say there is a double bond here also. There is a double bond here. After addition of the hydrogen in the presence of platinum, palladium, or a nickel, what it will do? It will reduce this. It will as well as reduce this. Means this reduction of this means addition of the hydrogen. This will change to CH3. This will change to CH2, and also this will change to alcohol. Like this is the compound what you are going to get. This is the first reducing agent which we should know. A very good reducing agent. Then second reducing agent will focus is sodium in the presence of ethyl alcohol. Sodium in presence of ethyl alcohol, right? Or a sodium. It may be written on the arrow. Sodium plus ethanol, or it could be also written as sodium plus C2H5OH. This is another reducing agent. Third reducing agent is a lithium aluminum hydride. Okay, this is very strong reducing agent. It is a very good reducing agent. We can say it can reduce aldehyde. It can reduce aldehyde to carboxylic. Sorry, it can reduce aldehyde to primary alcohol. Okay, and it can also reduce carboxylic acid to primary alcohol. Means here a main point to remember, this is not going to reduce double bond. Understand this. Double bond or triple bond, right? This is a important point you should know. Like this hydrogen, it touches the double bond also, no? It is not going to reduce it. Same way over here. This is also not going to reduce this. I'm talking sodium in the presence of alcohol. This is not going to reduce reduce uh, double bond or a triple bond, right? Here also you should remember this. Here this reduces, no? And the other reducing agent which we know is a sodium borohydride. Fourth is a NaBH4, right? This is also works in a same manner, but it doesn't reduce. The point to remember, reducing agent does not reduce carboxylic acid, carboxylic acid to primary alcohol. Remember this. It can reduce aldehyde to primary alcohol. Reduces uh, aldehyde to primary alcohol, and it also reduces ketone to secondary alcohol. Okay, here also same. It reduces ketone to secondary alcohol. Now this point which I have mentioned, it does not going to reduce a double bond or triple bond. It is true for this also. Sodium borohydride and a lithium borohydride. This point is true for this, right? This is the whole idea about the reducing agent. Make a note of this. So because you should be very much flexible while choosing the reducing agent. Now if we compare between a lithium aluminum hydride, lithium aluminum hydride and a sodium borohydride. Remember that this is a strong reducing agent. This is strong reducing agent than this. So lithium aluminum hydride is stronger reducing agent than sodium borohydride. What is the reason for that? Is that why this is strong? What is the reason? If you compare a size of the aluminum, here there is aluminum hydrogen and here it is boron hydrogen. Aluminum hydrogen bond length is bigger than boron hydrogen. Why aluminum? What is the meaning of bond length? This let's say this is aluminum atom and this is hydrogen. So distance between the two nuclei is a bond length. This is the bond length, right? This is a bond length, right? This is aluminum and this is hydrogen. Whereas boron is a smaller atom compared to the aluminum, and this is the hydrogen atom connected to it. So this is the bond length. So here bond length is small. Here bond length of the boron hydrogen is small. That's why bond strength is more. Not able to give its H minus very easily, right? This can give its H minus very easily. This can give, or a lithium aluminum hydride can donate H minus easily. H minus it is. So these are the since aluminum hydrogen bond length is high compared compared to boron hydrogen bond length in sodium borohydride, right? So therefore aluminum hydrogen bond is weak. Bond is weak. Therefore it gives more of H minus, right? So that's why this is good reducing agent. Many times they do ask a reason why this is stronger and why this is weak. So now let us move on to the reactions of the reductions. So first reaction we'll do the reduction of the aldehyde. First I'll write a reduction of aldehyde. Reduction of aldehyde. See, if you reduce aldehyde, let's take this R C double bond OH. This is an example of the aldehyde. So you can choose any of the reducing agent. Like you can choose hydrogen in the presence of nickel, platinum, or a palladium, or you can choose sodium in the presence of C2H5OH. This is ethanol. Or you can also choose lithium aluminum hydride or a sodium borohydride. We can choose any of this. Okay. This will finally land you to a primary alcohol, that is RCH2OH. Means if I have a compound this way, if I have a compound this way, CH3, CH2, C double bond, OH. What is the name of this compound? Name of this compound is propanol. It is propanol. And if you put a same reducing agent, the above reducing agent, same, this, the compound what you are going to get over here is this CH3, CH2, CH2, OH. The compound name is a propane. It is propane 1 all, right? This is about the aldehyde. Uh, we can do the reduction of the ketone also. We can do the reduction of the ketone. Reduction of the ketone is this. General formula of the ketone is this. Both the things may be same or may not be same. So what we can do is we can use the reducing agents. We can use the reducing agents like same hydrogen in the presence of nickel or platinum or palladium. Okay, this is one of the reducing agent we can use, or same like sodium, or I will put any one, C2H5OH, or we can use a lithium aluminum hydride or sodium borohydride. Means what you are going to get over here is this R C double bond O. Sorry, what you are going to get is a secondary alcohol, right? So this was the ketone. This was the ketone which we started with. Now ketone means we can take these examples. We'll do these examples. This is an example of the ketone. This is also known as a propanone. This is a propanone, or in other word, it is also called as a acetone. So this reducing agents are what? Which were shown on the top. Same reducing agent. I am not writing it. So this reducing agent, what it will get converted? It will get converted to this. It will get converted to this, right? That is propane to all. Now, if you take this type of ketone, if I take this type of ketone, that is butanone. This is also butanone. And if we put the same reducing agent, it is going to give me a OH and a CH3. So this is what? This is giving you a secondary alcohol. Here name will be what? Butan 2 all. So this is the thing about the reducing agents of the aldehydes and a ketone. Now, reduction of the carboxylic acid. Third is, or I'll write reduction, reduction of carboxylic acids. So carboxylic acid is this way. How do we represent carboxylic acid? C double bond OH. This is carboxylic acid. The reducing agent. You have to use the strongest reducing agent. Among all this reducing agent we discussed so far, which is the strongest reducing agent? The answer is lithium aluminum hydride. This is the strongest reducing agent. So you are going to use this only. So this in the presence of water. Water is a solvent over here, and this will get converted to this R CH2OH. Means if we are having a carboxylic acid this way, if we are having the carboxylic acid this way, CH3 COOH. This is a 1 and 2. This is ethanoic acid. Ethanoic acid. And if you are putting the same reagents, what you are going to get is CH3, CH2OH, that is ethanol. If I take some other carboxylic acid, like this is what four carbon system. So it is a butanoic acid, butanoic acid, and you put the same reducing agents like lithium aluminum hydride only. Here it is very specific. You cannot use any of the reducing agent to convert it a carboxylic acid to aldehyde. If you are using a sodium borohydride, it is a weak. It will reaction will stop just at a aldehyde. You won't get a primary alcohol. So here this will be giving you CH3, CH2, 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 and OH. So this is butan one all. This is a primary alcohol which you're getting. So these are the whole reaction in a simplest manner. That flowchart is always going to help you. Next is reduction of the ester. Next is reduction of esters. So reduction of the esters over here. First we'll take a ester. How does the ester look? C R C double bond O R dash. This is what the ester representation. And if you use a reducing agents like lithium, aluminum hydride in water, okay, or like this water, we or you can write plus water, plus water, or you can write sodium in the presence of ethanol. This is also a reducing agent. What you are going to get is R CH2 OH, one alcohol over here, and other is R dash OH. And you are going to get two alcohols. If my ester is this, if my ester is this CH3, C double bond O, OCH3. If this is the ester, and if you are using the reducing agents, then it will be CH3, CH2, OH, and other is this, right? That is CH3OH. Means ethanol, ethanol, and a methanol, right? So these will be two products. If you use a ester this way, if you use a ester this way, this is a ester, and same reducing agents you are using, then the compound what you are going to get is this. So both alcohol are primary, and this is the what you are going to like one. This chain will give you one alcohol, and this will give you another alcohol. That is how you can remember. So here it will be what propane one all, propane one all, and here it is ethanol two alcohols which you are going to get over here. So in all these things, in summary, if you want to write a summary of all this reaction, what is important to note? Okay, very important note I'll write. Important note. Remember this. This note is very important. So first is uh, from this reduction method, we cannot prepare from reduction processes, from reduction of the carbonyl. Carbonyl means from reduction of carbonyl, that is aldehyde and ketone. We cannot prepare a tertiary alcohol. This is one thing about this reduction processes. Then sodium borohydride is less has less reducing nature, less reducing nature compared to lithium aluminum hydride. And third, sodium borohydride, remember this, cannot reduce acid, cannot reduce acid and its derivative, except this is an exception. It can reduce this RCOCl. RCOCl means it is this. This is a derivative of the acid. It can reduce this. Acid halides it can reduce. This is the whole summary, very important thing. So next chapter, next topic. So next lecture 4, I'll be doing the reactions with the Grignard reagent where we can produce a tertiary alcohol also. So I'll end this chapter, end this lecture over here. It is already half an hour. Usually what I do is I keep the lecture duration to be almost half an hour. So if you feel that this knowledge was very useful and it helped you a lot how to understand organic chemistry, if you find this video very helpful, you can share among your friends, okay, so that it helps me also to make more videos like this. Thank you so much.